up 2 sheets. This one is the notes for the day, the practice problem. This one is what I'm going to be calling your SHRATEY cheat sheet. And you'll be able to use this on your quizzes and tests. I'll actually have a class copy. You won't be able to use your own copy, but you'll still have a copy of it. If I say copy one more time, I'm gonna screen. Did I? I've been doing it all day. I just keep saying the same stuff over and over. So yesterday, here's what we talked about yesterday. We talked about rational functions, which are functions that are written as a fraction, but specifically have a variable in the denominator. They could have it in the top two, but for sure in the bottom. And we talked about these basic graphs. For this one, looks like this, for 1 over x. And this one looks like this. And we even talked about shifting them, right? Left, right, up, or down. I'm sorry, I should have said you don't have to write this down. I'm about to erase it. It's just a set. It's just for a quick review of what we talked about yesterday. But I forgot what I was saying. Oh, we talked about how you could shift it, and we could write the equations for that, right? The HK form. But even though we talked about that yesterday to write an equation, no matter how sophisticated we got with yesterday's skills, it's not enough to be able to graph something that looks like this. Okay, that's a whole different beast. There's x squareds and x in it, so there's no way we could go from here to the graph of that. And that is what your SHRATEY cheat sheet is for. A bunch of steps to figure out SHRATEY. Your SHRATEY cheat sheet is all the different steps you can take to find the important parts of this graph, which at the end of the lesson we'll use to sketch a rough graph of the graph. So that's our goal for today. Let me erase this. I'm going to write this bigger so I can see it. I want you to, okay, so SHRATEY is a handy acronym, right? SHRATEY. What I want you to do is take a moment, be sure you're on the side with the S on top, and read the S section. So take a moment and read the S section. Also, don't write this down, I'm about to write down. In baby math, if I told you to simplify 9 over 6, what would your answer be? 3 over 2. How'd you do that? What was the actual math behind that? Divide by the greatest common factor. That was beautiful what you just said. So you divide the top and bottom by 3, right? And that gives you the 3 halves. What you may not remember when you first learned that process is we broke it down into its factors, its prime factors, and canceled out anything that was the same in the top and bottom. And I hope that as I was explaining that, you realize that's what you just read in the S section, right? The S section says factor the numerator, which I did, factor the denominator, which I did, and cancel anything that they have the same. Now that's baby math. Now we're going to have to do that same thing here with the algebra. Bless you. I think somebody was sneezing. Except instead of just factoring it into numbers, we have to use our factoring methods like GCF or grouping or difference of squares or the thing that starts with the cross, whether you're a swing method person or a grouping person, right? So those are things we all have to bring up from the recesses of our mathematical consciousness and do that today, all right? So here's what we're going to do. So instead of 3 times 3 on top, which would be really nice if it was that easy, we're going to factor using our algebraic factoring methods. Raise your hand. So I want you to think about the top for a minute. I don't want you to holler anything out. But raise your hand when you feel like you know how to factor the top, the numerator. Raise your hand if it's still just the second day back from break and you'd like me to help you out on that a little bit. Okay. All right. So the x squared plus 3x, that's a GCF. Okay. What do they have in common? X, right? So we're going to factor the x out and write the leftovers in parentheses. It's reverse distributive, right? You're dividing out something instead of multiplying it through. But if you did distribute a property, you could check yourself and you'd find that you were correct in the way that you factored. So the numerator is factored. Now look at the bottom. Try to remember something about how we might factor the bottom. I do want you to use your brain a little bit for 5 seconds. Go. Raise your hand if you came up with something. What did you come up with? Did you come up with do you remember how to factor the trinomial? Okay. So you start with the cross, and you're either going to do grouping or swing. I like the swing method. And so here's how that looks. What multiplies to -3 and adds to -2? It's -3 and +1. Dividing by the a value doesn't change anything. And the way you use those numbers is you just take them, you put an x in front, and boom, you have factors. You do not change the signs. This is one of the times when it's not an insider's lie, all right? So it's just, you keep the signs the same, x - 3, x + 1. So we have factored the top, and we have factored the bottom. But just like when we had 9/6, we had to look for stuff that cancels. What do you see that might cancel here? What's the same in the top and bottom? What's the same in the top and bottom? Nothing, right? Nothing's the same. So we can't cancel anything out. One thing I do want to bring to your attention is when you're trying to see which factors cancel, if it's got parentheses around it, you're looking at that whole thing as a group. This x all by itself is not available for canceling because it belongs to the +1. This x could be canceled with some other random x, but not if it's attached to something else with a plus or minus. Okay? Factors are things that are being multiplied, so you have to be careful. So nothing cancels. So that's fine. Read your H section, please. What does the H stand for? Holes. So holes mean, like, if you ever see an open circle on a graph, that means it's undefined, okay? The word hole is an oversimplification, and it starts with an H, which makes it cute for our acronym. The math speak for that is it's a discontinuity, right? It's just not defined there. And holes are created by any factors that do what on your H section? Cancel. Did I cancel anything here? Nope. So I'm not going to have any holes. So that's an NA. It's a big fat no right there. Which I guess a big fat no would look like this. But stupid, right? Okay. All right. sorry. Just ignore me. I'm just up here to amuse myself, apparently. Okay. So read the R section to yourself, please, and thank you. And never mind what I draw on the board is stupid. All right. So what does the R stand for? Roots. It's not like the gray ones that I have coming out of my hair because I have to go get a box color from the store and pine. What are some other words we have for roots in math? Zeros. What else? Intercepts. The x-intercepts. Solutions. Okay. So the R section is for roots. What does it say right next to the word roots? Tell me out loud. Solution to the top. Top. What does that mean? Top. Top of what? Do you think? Top of the fraction. Top of the fraction. It means the numerator. Okay. So To find the roots for the graph, you're finding the solution to the top, or the numerator. Now I have two forms of the numerator here. I have this original one, and this factored one. I'm going to use the factored one, okay? If you were to read your roots section again, it says to set the numerator equal to 0 and solve. If I took the original form and set it equal to 0, guess what I would have to do before I could even keep working? Factor it. So you might as well just start with the factored form anyway, okay? Because you already went through that trouble. I really don't want this here. So I've got x times x plus 3 equals 0. If you remember from factoring last semester, your zero product property says, once you get it in factored form and it equals 0, you take each of those factors and break them up into their own baby equations that equal 0. So x equals 0 and x plus 3 equals 0. And then you solve those. Which one doesn't even need to be solved because it's already done? X equals 0, right? Nothing else to do there. Nothing else to say move along. But on this one, you have to subtract 3 to both sides, and I get x equals negative 3. Which is fine and dandy, but put your eyes back on your R section. There's the R, roots. Sentence, sentence, sentence. Right after where it says set numerator equal to 0, I want you to read the next sentence after that to yourself in your brain. It says write the answers as what? What word? Points, okay? That's very important because I'll take off if you don't. These are roots, okay? X-intercepts. They're points. You want to write them as ordered pairs. If you leave it here, x equals 0 and x equals negative 3, this is actually the equations for lines. Okay, so you want to write it as a point, and it even tells you how to do it. It says number, comma, 0. So whatever numbers you got when you solved, that goes in your x spot, and then 0, because these are x-intercepts. So we've got 0, 0, and negative 3, 0. And you can put those on your graph. So we found our roots. We set the top equal to 0. The next step is setting the bottom equal to 0. What does that letter A stand for? Asymptotes. It does stand for asymptotes. Yesterday, and you don't have to write this down. Yesterday, when we had something like this, there was actually two asymptotes. This one, that's vertical, and this one, that's horizontal. Which one does your A section deal with? Vertical, okay, and it says that right there. So that's, we'll talk about the horizontal ones later on in the acronym. So this one is for vertical asymptotes only. So roots are, you set the top equal to 0. Asymptotes, vertical A, you set the, wait, did I say bottom? Anyway, set the bottom equal to 0 for A. So, and do you think I'm going to use the factored form or the original form here? Factored, absolutely. You already did that work, roll with it, okay? So here I got x minus 3, x plus 1 equals 0. Because I set the bottom equal to 0, I use the factored form because it did have, that part of my work was already done. And then what? What do I do next? Set them equal to 0, those two little things. You need two little baby equations. They're going to be so cute. So x minus 3 equals 0. X plus 1 equals 0. Solve them. Blah, blah, blah. Math, math, math. And now I want you to think about how this answer gets written. And it tells you in your section right there, in the A section. It says write answers as what? X equals a number, right? You're going to write it as a line, because that's what asymptotes are. They're lines. Am I already in that form, or do I have to change it? I don't have to change it. I'm good. This is the form I need. And here's how you're going to put those on your graph, okay? They're vertical asymptotes. You're not going to use a solid line because it's not actually your graph. It's an imaginary boundary line that determines the behavior of the graph. So what we're going to do instead of a solid line is a dashed line. So for x equals 3, I come over here to my graph. X equals 3 right here, which I'm sure we're all agreed on. However, it also equals 3 here, and here, and here, and here, and down here, and down here. And like I could do this game all day, right? Because it's infinity. And so this is why it's an equation of a line, because it's infinitely many points where x equals 3. And so we're going to do this. Okay. The dashes mean it's not really part of your graph, but it is an imaginary line that determines what's happening on either side. Same thing at x equals -1 right there. Blah, blah, blah. Color, color, color. So now I have some stuff. I have roots. I have vertical asymptotes. What's the next letter? T. T is obnoxious. Take a moment and read that whole section, please. I want you to write something back on your T section. I really, really am serious about wanting you to write this down. Am I serious about this? Okay. Write this down on your T section. Okay? When you're looking if something is squared, you're going to use that factored form that you did in step S. For your T step. Are you going to use the original form or the factored form? Thank you. Yes, that's true. That's true. All right. Did you have enough time to read the E part? Yeah? Okay, thank you. All right, so E is talking about end behavior. So end behavior means the behavior at the what's? The ends, right? What does that even mean? What do I mean when I say the behavior at the ends? Like, do I mean like -10, that's kind of far? Is that the end? -20, is that the end? I mean negative what? Infinity, positive infinity. I mean on the way ends, all right? So this next step, E, is just for your end behavior. It also happens to be a more asymptote information. But it's not your vertical asymptote. So if it's not the vertical asymptote, it's which kind? Horizontal. Okay. So the E step for end behavior is for your horizontal asymptotes. I want you to do something on that table, and I want you to just cross out the middle section. We won't have any that are top heavy. Those are oblique asymptotes, meaning they're slanted. And we won't be doing any problems like that. We'll be doing strictly horizontal ones. So cross out the middle part of your table. And then I want you to write next to the E somewhere that this is horizontal asymptotes. I want you to make a note out on the side. I want you to write it with your own handwriting, with your pencil, because it's good for your brain. This is for horizontal asymptotes. It does say that it's embedded in there somewhere, but this way at least, yeah, it stands out. It's the 7th period. We're at 325. Okay, that's right. And then I want you, so put your eyes on that paragraph and have your pencil ready. There's some stuff I want you to mark. So it says, this tells how the graph looks only on the ends. Do you see how ends is underlined? Yeah, I want you to circle it too, so you can remember that. to the left and right. And then it says this, write out the leading terms for the top and bottom. Write out the leading terms for the top and bottom. Here's what that means. The leading terms are the first term. So this is the leading term here, and this is the leading term here. Did I use the factored form or the original form for this step? The original form, okay? So for step E, you're using the original form. Can we say that one more time? Original form, original form, original form. Yeah, it wouldn't hurt. And in this case, so in this particular problem, when I write them out, it looks like this, x squared over x squared. And then it says, I want you to put your eyes back on the paragraph so you can read the words while I'm reading them to you. Decide on one of the three categories below. It's actually really now two, because we cut one out. And then reduce the leading terms if necessary. So here's what those two categories mean. So you see where it says balanced? That is when the exponent on top, the degree, is the same as the one on bottom. Bottom heavy, excuse me, is when the degree on bottom is bigger than the degree on top. Which do I have, balanced or bottom heavy? Balanced, okay. So that's going to give me a horizontal asymptote. It says, write as a line y equals some number. Well, that's fabulous. Where am I going to get that number from? This step right here, where it says reduce if necessary. This can be reduced. What is x squared divided by x squared? 1. There's my number. So that's my horizontal asymptote. Y equals 1. Now this is an asymptote. Am I going to graph it with a solid line or a dashed line or what? Dashed, because it's just an imaginary boundary. It's not actually part of the graph. And it's horizontal. So I'm going to put that in my graph, y equals 1. Dash, 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 dash. Now, if I was still here in that balanced part of the table, it says graph this line or at least its ends. Now, I graphed the whole line straight across. Because this is only determining the end behavior, you technically really don't need all of these dashes in the middle. But in the past, when I've only included the ends, students get frustrated with me because they forget why I do that. So I just put the whole thing. Okay, but you can do whichever you like. Have we gone through all the letters yet? No, we have to do Y. But it's the easiest one in the whole. It's the easiest one in the whole thing, pretty much. So what does Y stand for? Well, what does it stand for? Y-intercept. Y-intercept is where the graph is going to cross the y-axis. What does x equal everywhere on that line? 0. And so that's why on your Y section it says to plug 0 in for x. So we're going to do that. You can use either your factored form or the original. I think I'd have this memorized by now, but I do not. So here's how that's going to go. 0 squared plus 3 times 0 over 0 squared minus 2 times 0 minus 3. And then you do your order of operations, and it's not really hard because it's all zeros everywhere. Math, 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 math. And you get 0. And then it says write as a point 0, comma, whatever your number was. The number I got was 0. So it's 0, 0. Which should not be a surprise to anybody because we already had that, right? That's the x-intercept and the y-intercept. So the reason why I ran through the math, though, was just for consistency, just to show you how the math would have gone. You won't always get 0, 0. All right, so graph that point. We already have it graphed, so we're good. All right, so we just went through like a whole bunch of work. 6 1,000 years worth of math right there. Do I have a graph? A finished graph? No. It looks like I have almost nothing. But we can use our wits and our cunning and our math skills to finish sketching this graph, okay? And some of this information we're still not done with. We're going to use it again. So here's how this is going to go. Those two vertical asymptotes break the graph up into 3 sections, okay? Whatever is happening to the left here of this asymptote, whatever's happening in the middle of them, and whatever's happening to the right. These problems, once we get into our practice problems tomorrow, they all have like their own different flavor. There's no like one method that you can do for each one and come out correctly. You have to use your brain each new set. And the reason why I'm even saying all that is because you sometimes could start in the middle if you had more information already there. Or sometimes you could start on the right. But for me to be consistent up here, what I'm going to do each time is figure out the left side, and then the middle, and then the right. If you're like a ninja, and you can start wherever you want, you are free to do that, as long as you get the right answer, okay? But I'm starting on the left, and so here's how that's going to go. So I'm on the left of this asymptote. I have this one measly point right here, which isn't really enough information to get started at all. And the reason is because what I don't know, like I know some things. I know that as x goes towards this asymptote, it's going to approach it. It's either going to go up this way or it's going to go down that way. So I don't really know if the graph is going to go through this point like this or if it's going to go through the point this way. Like I don't know. But I could figure it out if I wanted to. What would be really nice for me to have right now to go with this other thing that I have? Like I need 2 points. It would be great if I had a second point. Because no matter where that second point was, it would help me figure out the shape of the graph right here. And we can find a point whenever we want to. We didn't have to go through all that work to get a point. How do you get a point at any time in history that you want to get a point? What do you do? It's not even fancy. You plug in. You pick an x point, you plug it in, and you solve for y, right? That's all you have to do. It's a test point. So that's what I'm going to do. And again, the reason why I need a test point is to figure out how the graph is going to cross through this root right here. So I'm going to pick x equals -2. You see where -2 is right here? Test point, x equals -2. How do I find the y that goes with that? What do I do? Why do I do with that -2? Plug it in at the top. Plug it into your original equation. So that's going to look like this. -2 squared plus 3 times -2 over -2 squared minus 2 times -2 minus 3. And if you were so lucky as to have a friend who already did this math work for you, you would have this answer. -2/5. Okay? If you did your math fine and you handled the negatives correctly and your order of operations was spot on, you would get that. And so that would give you this test point, -2, -2/5. And then you put it on your graph. Boom. Okay. Now that I have that second point, I can sketch a decent shape for this portion of the graph. Because I know, just from their placement, that the graph is going to go through them like this. By the way, how do I know the graph is going to go through the root and not bounce off the root? Which letter tells me that? Which letter from SHRATEY? The T, right? Not tangent. Remember, anything in the top is talking about the roots. The roots are not tangent, which means they're not bouncing there. And then here's other stuff that I know. I know that as the x values go out to negative infinity, that's end behavior. That's what this horizontal asymptote is for. That it's approaching from below, and it's getting closer and closer to that line without ever actually hitting it. Okay? So it's going to go like that. And then as x is coming in, remember we talked about that yesterday, as x is going out, as x is coming in. So as x is coming into this asymptote, it's just going down. It's getting closer and closer and closer, but never reaching it. Okay? And so now I have this basic form right here. The test point was key to figuring out that shape right there. But now I can pretty much just Sherlock Holmes my way through the whole rest of the graph. And we're not even doing any more test points. You always could if you felt like things were, if it gives you comfort to do test points, you're welcome to. But here's just how you could sort of do some critical thinking to get the rest of the parts. This right here. So I just came up to this asymptote, and I need to know what the graph is going to do on the other side. Which of these letters talks to me about the behavior on either side of the asymptote? Which letter from your SHRATEY? T is for end behavior. T, right? So T says the graph does not come together at the asymptotes. Remember, anything on the bottom is asymptote information. So right here, I know that on the left side of this asymptote, the graph is going down. If it was this piece, whatever it looks like here, was coming together, it would be like this. It would be going down on that side as well. That's coming together. But we said what? That it's not coming together. So if it's not going down, what's its only other option? It's opposite of down. Up, absolutely. Good job, Bill. It has to be going up on this side. Okay? So it's not going down, it's going up. Because it's not coming together, it's going apart. So then you're looking at it, you're like, okay, that's fine, I know that. It's got to cross through this root somehow. It has two options. It can bounce at that root, or it can cross through it. What have we already determined? It's not going to bounce. It's going to go through. It's not tangent. So it's going to go through. And then let me just show you the other part of the graph real fast. It's going to go like this because of T. Thank you very much. Y'all have a wonderful day.